part will do it. (99 ohm, 1 ohm, 100 volt, and the capacitance. So it will have a charge minus Q naught plus Q naught. We'll calculate Q naught. Q naught should be equal to 10 coulombs. Then half of the work done by the cell will be stored in the capacitor. Remaining of will be taken by this. So therefore, this heat generated. So what is asking? Calculate heat generated 99 ohm. This should be equal to U, because this should also be equal to heat, no? So what is the basic idea? What all the cell does work, a half of it will be stored in capacitor. Remaining of what will be shared by these two. What all that heat generated, again, that heat, what happened, a part will be there dissipated by the cell, remaining what happened by this resistor. So these two are in series. So therefore, what is the method? So this should be equal to H should be equal to 99 by 99 plus 1. Or I'll write in terms of formula. The same potential divider formula for heat generated also you should use. What is H? H should be again this one, because what is work done by cell, half of it will be there in capacitor, remaining of will be there, no? So therefore I can write UH. Simple. You can avoid, don't go for calculation current at any time. See, this problem is specifically brought so that, oh, what happened? Yeah. There we are. Try to see this. Say we will get tempted of what going for integration. Not needed, no. We know that variable current flows here. So, but don't go for that getting expression for current and then integrating. It'll be very lengthy. This will be much easier method. Now the switch is thrown to position 2 at an instant t equals 0. Means it get fully charged. It got fully charged here. Now it will be thrown that one. So now here, what is the drop here? Will be 100 volt. Will be 100 volt. But the battery cell is of 50 volt. So just have a small diagram. The question is like this. Internal resistance, keep symbol here. So what was the drop here? Q naught minus Q naught. Definitely this is 100 volt. Just do indicate like this. Now you're going to switch. So what happened to capacitor? Will it charge or discharge? If you're going to discharge here, then finally what will happen? Finally, what do you expect? The charge here will be Q. And how much potential drop? Should be 50. No need to integrate. So what is Q? Q should be C into 50. C is how much? 0.1 into 50, 5 coulomb. What happened that earlier was 10 coulomb, the 10 coulomb, now it has become 5 coulomb. So what charge has flown at any instant of time, if you are showing this is after long time. At any instant of time, how the circuit will be? At any instant of time, the circuit, there'll be flow of current. From where? From the capacitor to the cell. Just only say like how you analyze the situation is what the questions are being asked here. So at any instant of time, again, if you check it now, the current will flow in this direction. Tell me like why a broad current, so that you should look at the circuit here now. So now what is the state of this cell? It is getting charged or discharged? It is getting discharged here. The cell is getting discharged.
Charge, sir.
Okay, sorry, charging. Sorry, charging it is. Here, this cell was discharging. Here, this will get charged here because the current enters positive terminal of its cell. Okay, finally, what happened? The energy that was there in capacitor, what happened to it? Is it all the energy given to the cell? Is it all the energy converted as heat? No. The decrease in potential of capacitor. So what will happen to this? A part of that will be given to cell. A part will be converted as heat. Is asking to get expression for current. I think you know how to calculate the current. Again, write the loop equation, get expression for it. Now let me come further. Calculate heat generated in 50-volt battery during flow of current through this battery. How much of heat will be generated? Because there's internal resistance, there'll be some heat will be generated. Now first we'll calculate the decrease in potential, delta U. Delta U should be equal to Q square by 2C, Q naught square by 2C, Q square by 2C. 10 square, 2 into 0.1 minus 5 square, 2 into 0.1. Anybody value?
375.
375. Yeah. There's a decrease in potential. Where do all this has gone? So what is the energy stored in the cell? The difference in charge Q minus Q naught into 50 volt. If you want, you write E2 symbols. So 10 minus 5 into 50. So this will be 250 joules will be stored. Okay, clear this. The remaining how much will be there? 125. That 125 who will share this capital R and small r. So the heat generated in the second process, we took here. I'll write H dash. This H dash should be equal to HR plus HR2. How to calculate H dash? The difference of this delta U minus H, this one energy stored in the cell. So the difference of that will be H dash here. So H dash will be 375 is equal to HR plus HR2. So what is asking? Calculate heat generated in the cell. What is heat generated in the cell? The heat that is generated across this internal resistance, that is asking. But both are unknown. So again, how they are in series, no? If they're in series, so what is the formula? HR by HR2 should be equal to R by R2. We'll agree this formula. Potential divider formula. The same thing for energy also. Power dissipated. The ratio of power dissipated when two resistors are in series. Power or energy, heat, both will be same, no? Now replace HR here. So like this, this will be 125, no? So HR2 should be equal to 125 R2 by R plus R2. What potential divide this one? So substitute this, you'll get the required answer. Even so, what is the what you should take this one? What is the total energy? Anybody HR2? Because I want
1.25.
One. It's given here, no? 1.25. I'll write it. And what is the total energy available to the cell? $250 plus 1.25, 251.25, of which 250 it will store, remaining it will dissipate. This is not useful, this is useful. I have to write comment. This is a useful energy stored in cell. Useful energy I should call it. In exam, instead of saying stono, what was the useful energy that was given to the cell? Tell me what you should say. You have to say this one. Given to the cell, for the cell, it is given both. This is what has been lost as heat. The terminology of asking questions will be very, very critical. Lost as it. Able to get this one? Total energy given to the cell is sum of these two. You